All right, boys and girls, now we're moving on to example 5. And in example 5, they want you to find the arc length, okay? And in order to do that, we're given the formula S equals R times theta. Okay, so a couple things you need to know. Um, S is the arc length, okay? S is going to represent the arc length. I know you've seen it before when we've done the circle. R is, of course, your radius, okay? And theta is your central angle. Okay. And don't forget your central angle is measured in radians, okay? In radians. So you'll see it as rad. So it's measured in radians. Okay? Okay, so keep this formula in mind because this is the one you're going to be using. S equals R times theta. Okay? And so let's move on to our first example. Okay, boys and girls, so I drew a picture. Again, you can follow your textbook. This is an extra example, so it's not a problem directly from the book, so you can always do the other examples in the book, okay? So I drew a visual, but this is what the problem reads. A circle has a radius of 10 inches. Find the arc length intercepted by a central angle of 140 degrees. So I kind of just drew the visual for you. The visual is not necessary, but it's there for you to see, okay? So this right here is your S. That's the arc length. So that's what we're trying to figure out, okay? So remember, 10 inches is our radius and our central angle is 140. So basically, I can write R is 10 inches, theta is 140, of course, degree, and our formula is arc length equals R times theta, okay? So remember what I said earlier, theta is always, or our central angle is always measured in radians. And if you look here, they gave it to us in degrees. So the first thing we have to do is change 140 degrees to radians. So I need to have it in radians, okay? And then in day 1, I taught you how to do that. So I'm going to do that right underneath, okay? So we're going to take 140 degrees, and in order to rewrite it in radians, I need to multiply it by pi times 180, okay? And then rad, okay? So remember, 140 is in degrees and 180 is in degrees, okay? So the degrees portion, that's going to cancel out, okay? Degrees is gone. And then I can simplify this, okay? 140 and 80, first of all, I can get rid of that. Can simplify by 10. And then we're left with, let me move this up. We're left with 14 and 18. And I can simplify this. And so we're left now, I can simplify by 2, sorry. 7 and 9, okay? And so what I would be left with is 7 pi over 9 rad. And that's basically my my new theta, okay? This is my new theta. Okay. All right, so now that I have everything that I need, I can put it back in the formula, okay? So remember my radius is 10 and my new theta is 7 pi over 9. Okay, guys, so we could multiply this without a calculator. And I'm running out of room, so I'm just going to go up, okay? I apologize. So 70 pi over 9. Okay, now because we're finding an arc length, then I'm going to go ahead and simplify this. So now I could just use a calculator, okay? So in my calculator, I would just put 70, and of course this calculator has the pi features, so I would just multiply that and then divide it by 9. And so approximately this is what it's going to give me. And I always want to keep 2 decimal places. So my final answer, I would say, would be, and I'm going to keep going up. Sorry, guys, I run out of room. S is approximately 24.5 43 inches, and that's my arc length. Okay. There is an example in the book, and there is a checkpoint. I actually recommend that you try those, or that you look at those over, okay? All right, guys, let me give you an example for you to try.